Hello and welcome, students. We are going to show how to do some reasoning and introductory to proof writing kind of thing. So the big idea with the things that we will see today is that you're going to have a picture and it's going to have multiple steps to it with some information to get you started. But with each step that we do, we want to start thinking about why we can do that step. So it's kind of justifying our process all the way through. So when we have these pictures, you can click on each one and then click on the edit tool. I'll make this bigger so it appears bigger on your screen. So I'll click on a picture, and then down here below it I see edit. What I want us to do is work our way through to kind of create a path to get to the angle that we're looking for. So our finishing angle is going to be find measure of angle B up here. But I'll have some information that will help me kind of work my way through. So first, I'm going to use this text box, and I'm going to say, all right, if that left side is 111, then this has to add up to 180. That would make this other angle 69 degrees, and then I can say more information based on what's written here. It says that AB and BC are congruent. So I can mark both of those sides with a little line tool. Now I'm going to copy and paste this angle measure because it's true for both sides. This is an isosceles triangle that kind of that will split or fold in half down this vertical line. I'll make it kind of dashed there so you can see on that dashed line it would fold in half. Then I know that these two angles plus the third angle, which is angle B, that those three angles are going to add up to 180 degrees. So I'm going to copy and paste again. I'm going to do a couple of things here. I'm going to say this plus itself plus angle B is going to add up to 180. That means I'm going to have 120 plus 18, or 138 plus B is going to equal 180. So B in the end should be subtract from 138 from 180, and that's going to be 42. So B equals 42. Angle B equals 42. So I'm going to copy and paste this text box again. I'll put it up here and say that that's supposed to be 42 up in that corner. So through each of these pictures that we're looking at, we're trying to create a path that gives us the angle measurements that lead to the finish line that is chosen. Let's do another one. I'm going to click on the second one. I click on the picture, and then I clicked on the edit button below the picture. It tells us that 50 degrees is this angle. It also says that these two lines are congruent, AD and AE, so I'll mark those. Now if I click on this arrow to select the text box, that will help me figure out what the angles down below are. So this angle, the three angles need to add up to 180. So to find that third angle, let's do some calculations here. We could have 50 plus, let's call it x, plus another x, as in that's these two angles down here. The three of them add up to 180. When I subtract 50 from each side, I would get 2x equals 130. And therefore x is going to be 130 split in 2, or 65. Now you can also think of this kind of as just like, okay, the three angles have to add up to 180. These two are the same, so I could subtract 50 and then split it in 2. That's the same reasoning, just using like numerical calculations instead of algebraic steps. What that does for us though is it tells us that down here is 65 degrees. Make that text box a little bit bigger. And I'll copy and paste that. So is this one right there. Now once I know that's 65, I can actually find the angle next to it, because these two angles on either side of the point D add up to 180 as a linear pair. So 65 plus 115 would give us the linear pair. Now, what's neat about these parallel lines information is that kind of makes AB, DC parallel lines. I'm going to have some supplementary or adding up to 180 relationships with the same side interior angles, but in both directions. So I can say that 115 plus this angle up in this corner is going to add up to 180. I could have also said that 65 is going to be that angle based on alternate interior angles. Let's see if I can drag this in here. There we go. All right, so that one's 65, that one's 65. But then I use that same reasoning to kind of wrap around this angle here. So 65 plus 115, those make an equation that adds up to 180. And then again, we have, let's see, we're looking for BCD. This angle down here. So I didn't need these two angles up here. I could have just gone all the way across the bottom using the two 65s from the isosceles relationship, the 115 from the linear pair, and then this 65 from corresponding angles or same side interior angles. Either way would have worked. So lots of options there, but we're just trying to trace paths to get to kind of a finish line angle. All right, we have two other kind of versions of these pictures. Let's take a look at these. We have 25 degrees, 42 degrees, and we're trying to figure out measure of angle D all the way down there. So let's see what we can do with that. I'm going to copy and paste these text boxes a couple of times. These three angles, 25, 42, and this third one, have to be equal to a certain number. But I can also do some reasoning with these parallel lines. If I think of this almost like a Z shape from B to A to C to D, that 25 and this corner are going to be equal from alternate interior angles. So I have parallel lines. The 25s are interior to A, B, and C, D, and they're on opposite sides of this diagonal here. Similarly, this box and 42 are going to line up as alternate interior angles. So now I have that's 25 and that's 42. And these two angles plus angle D, I'll copy and paste so I can get a third angle in here, plus angle D are going to add up to 180. So I would add those two together. That's 67. So this in here is going to be like 180 minus 67. And 180 minus 60 is 120. Minus 7 more is going to be 113. So again, we're just kind of tracing our way through, trying to find a path to get to that final angle. Then there's more than one path. You don't have to do it the same way every time. Ooh, okay. All right, let's see what we have going on. We need to find CDE. So we're trying to find this angle to finish right there. If I had the other two angles here, that would help me so that I could add the three angles together to find a triangle. Let's see if I can get there. Well, the 27 is going to match up down here in this bottom right corner and up here in this top left corner because of alternate interior angles. Again, I have that parallel line Z shape. And this angle here is going to add to the 60 to make a linear pair, so that's going to be 120. Then these two angles, 27 and 120, would add together with the third angle to add up to 180. Those are 147. So 147 subtracted from 180 is going to be 33. So that would be our angle in the corner there. So we have 120, 27 plus 33. Is that correct? Seems like I'm slightly off, but I think it is correct. Yeah, that is correct. And that would give us our final angle there. There are other ways I could have done it. I could have said like, well, this is 60, or like, what am I going to find from linear pairs and other angles to find another angle and work my way all the way around. But this is probably the most direct route. Is that our final picture? Oh no, it just got a little bit bigger. Let's make it a little bit smaller for us. There we go. So we got all 4 of those answered. Now for these other ones, it's almost a little bit easier because I'm mostly focusing on what kind of relationship are we using to find the angles. So I see that I have 63 here, and I see that we have parallel lines going in both directions. I need to get to AJG. So AJG is all the way down in this corner. So let's kind of follow the pattern of what it's asking me to do. It says IKL, well, that's 63. It's already on the picture, and what we note for that is that it's given. Given means it's already there. I don't have to reason through any additional relationships. JLC, so now that's this corner. I can say that that relates to 63. That's like a copy and paste angle. So that's 63. It's the same. And copy paste angles are called corresponding. So that's corresponding angles. And then I have, so if this is, let's mark what that is. So what we just said was that this one is 63. And that means this one's also 63 for the same reason. It's a copy and paste from that bottom left corner to that bottom left corner. So I copy it from this intersection over to the other parallel intersection, and that's corresponding angles again. So that's 63, 63 from corresponding angles. Now let's look at this next one. We're trying to find FBC. So I'm going to put this box, make a copy of it. I'll put it down in the corner where it says FBC. And I think I can get there if I can find this angle. So let's see what happens with that one. BFC is equal to 74. That's already on the picture, that's given. GFC is equal to 35. That's also given on the picture. FCB. Okay, so that's a little bit different direction. FCB is down here. And FCB is going to be equal to 35 because that is a alternate interior angle. It's got that Z shape. Z shape is the ones that are alternate interior, and they are equal. That tells me that this one's 35, and now I have a triangle with 2 angles, but I'm missing a third. Whenever I have that, I can add the 2 angles, subtract from 180 to find the third. So these add, 70 and 30 is 100, 4 and 5 is 9. So that's 109. So in this corner, I'm going to have 180 minus 109. And that is going to be equal to 71. So that's going to be a 71 degrees in that corner. 71. And that is the sum of the angles inside a triangle. Let's do a couple more here, 3 more we have. All right, for this next picture, I have ABF is 134. That's given. Your first step is generally given. But now let's see what we can do with other ones. CGH is also given. That's 80 degrees. IFG. So IFG. I think we're going to need almost another angle in between. So let's say that we had FBC. So I'm going to copy this, paste it. On your original or your final version, you will already have this here. So FBC. FBC is here, and it adds as a linear pair to 134. So it has to add up to 180 from 134. So I'm trying to think, what's 180 minus 134? Well, 180 minus 130 is 50, and then minus 4 more is going to be 46. And that is a linear pair. So let's add that to our picture and see what that does for us. So this one, I'm going to copy and paste my text box. And I'll say this is a 46. And what's neat now is I can trace up here with a corresponding angle. And that's 46 there. And this angle across from here is going to be a vertical angle. That's 80. So the 46 and 46, those are corresponding angles. The 80 and 80, those are vertical angles, which will get me to my final angle because I'm going to add those with the third one to add up to 180 because they're inside a triangle. So 46 and 80 is 126. And that gives me up here that this should add up to 180. So that's going to be 54, because 54 plus 46, that's 100, and then 80 makes 180. Is 46. And that's from corresponding angles. And IGF is 80 from vertical angles, which makes I 54 from some of the angles inside a triangle. Okay, let's take a look at these last couple of questions here. We have this next one says, in the diagram below, we have a couple of things that are congruent, a couple of things that are parallel. Let's see what we can do with that. We're trying to eventually get over here where it says find measure of angle E. This one has just a few kind of steps to it, so let's see what we can do with these steps. There's more than one way to do it, but let's try and follow these steps here. I see that it has me do BCD, which is in the corner where I started, and then it goes next to CDA, that one there. So BCD is 65, that's given. And if I'm going to go in here and edit on this picture, I can copy and paste this text box, and it's asking me to find this one next. This should be 65, and this angle should add up to 180, because it's inside, same side interior of parallel lines. It has that U-turn shape kind of thing. So I'm going to say that this would have been 115, I believe. Yeah, so that's 115. And that's also going to make the one right next to it 65 here from a linear pair. Now, this tells me that a couple of things are congruent. These two lines here are congruent, which turns that into an isosceles triangle. And this 65 can copy itself over with like flipping to the other side because of that symmetry down the middle between the legs of a isosceles triangle. I could have also just jumped straight to the 65 with corresponding angles, but this one we want to include some variety. So now let's say what we had for each of these angles. We had 115, then back to 65, and 65 again. The 115 was that parallel lines U-turn, same side interior angles. So that's same side interior angles. ADE was a linear pair. And then we use an isosceles triangle to jump over to the other side. All right, now our final one here. This has a variety of things. And so let's start looking at the picture on what we want to do. So BGD, that's 42, because that's just given. CIH is also 100, which is also given. IGH, that's this angle here, that's going to be 42 from vertical angles. Let's mark that in the picture. I can add a little text box right here and call this 42. I'm going to copy and paste that so I can start doing some other angles like this one there, which is going to be 80, because these two angles make a linear pair. And that's our next one in line. GIH is a linear pair that makes 80. GHI is going to be the third angle down there in the bottom. So let's take this text box, I'll click on it, copy and paste it. This third angle, we have 42 and 80, and I got to subtract those from 180 to figure out this one. Well, 80 and 40 is 120, so that's 122. Now I have to add up to 180. I would get 58. I could use a calculator to confirm that, but that's what I would get for the third angle there. So that's 58. And that's from the interior angles of a triangle. Let's see if we can give ourselves a little bit more space here to see these answers. Then our final one, FHG, is actually going to be back to 122, because that's the angle outside here, because we have another linear pair. So I'll finish that on my picture as well. And I'll say this is a linear pair. I'm going to take this, copy and paste this text box. And this was 122. There we go. So we have all the way to our final angle. So a lot of these use these various angle relationships. Sometimes we have isosceles things, sometimes we have linear pairs, sometimes we have alternate interior or same side interior of parallel lines or corresponding from parallel lines. But it depends on what you are originally given, what kind of path you're going to take. This notes had a path kind of prescribed for you. It already told you a path to try, but these weren't the only paths to get to that concluding angle calculation. All right, that's all we have for this. Thank you.